Hi, I am Revathi. In this lecture series video of electron devices and circuits, today's topic is IGBT. Whether the content of this PPT includes basic structure, IV characteristics, switching characteristics, device limitations, and safe operating areas. Where the combination of BJT and P MOSFET is called IGBT. It is a high impedance input like a P MOSFET, low on-stage power loss like a BJT. In IGBT, second breakdown problem is not present. Voltage control device, three-terminal device. Some other names of IGBTs are metal oxide gate bipolar junction transistor, conductivity modulated field effect transistor, gate modulated field effect transistor, where the IGT device has undergone many improvement cycles to result in the modern insulated gate bipolar transistor IGBT. These devices have near ideal characteristics for high voltage, which is less than more than 100 volt, medium frequency, less than 20 kilohertz applications. This device, along with the MOSFET at low voltage, high frequency application, have the potential to replace the BJT completely. The basic structure includes the IGBT consists of P substrate and N substrate, where the P substrate is act as a collector and N substrate act as a metal emitter and gate circuit, where the gate circuit in the middle of the filling is act as a silicon dioxide, and the body of p-type is an injection layer, and n type is partially divided into two type, n substrate and current path, where the drift layer body of IGBTs are present in that area. The p layer is called injection layer because it inject holes into the n layer. The thickness of n layer determine voltage blocking capability of IGBT. A construction. So silicon oxide, gate oxide, body region, drain drift region, buffer layer, injecting layer, where the injecting layer act as a p-type, where the p-type transfer the holes to the n-type through the injection method. IGBT and P MOSFET are same in structure, but main difference between is in the substrate. In the N layer substrate at the drain in P MOSFET is now substitute in the IGBT by a P plus layer substrate is called collector C. The P layer is called body of IGBT. Equivalent circuit. Equivalent circuit consists of a collector, gate, emitter, a body region, parasitic transistor, and a drift region. Operating principle of IGBT. Operating principle of an IGBT can be explained in terms of schematic cell structure and equivalent circuits. From the input side, the IGBT behaves essentially as a MOSFET. Therefore, when the gate emitter voltage is less than the threshold voltage, no inversion layer is formed in the p-type region and device is in the off state. The forward voltage applied between the collector and the emitter drop almost entirely across the junction J2. Very small leakage current flows through the device under this condition. In terms of an equivalent current, when the gate emitter voltage is lower than the threshold voltage, the driving MOSFET of the Darlington configuration remains off, and hence the output PNP transistor also remains off. When the gate emitter voltage exceeds the threshold, an inversion layer forms in the P-type body region under the gate, where the inversion layer short the emitter and drain the drift layer, and an electron current flows from the emitter through this channel to the drain drift region. This is turn causes sustainable hole injection from the P plus type collector to the drain drift region, where the VI characteristics is represented in the graph method. They appear qualitatively similar to those of a logic level BJT, except that the controlling parameter is not the base current but the current emitter voltage. When the current emitter gate emitter voltage is below the threshold voltage, only a very small leakage current flows through the device, while the collector emitter voltage almost equal the supply voltage. The device under this condition is said to be operating in the cutoff region. Assessment. IGBT possesses IGBT and BJT both possesses the three terminals of the IGBTs are the IGBT, the P plus layer connected to the collector terminal is called as the controlling parameters in IGBT is the in IGBT the N layer above the P layer is called as the. Thank you.